We're going to look at some graphs and determine if the functions are even or odd. If a function is even, one way to think of it is if you were to fold on the y-axis, everything would match up. But another way to think of it is the points are going to jump across the y-axis. So in my picture here, I have this upside down V. This red dot is 1 away from the y-axis. If it jumped across, it'd be right there. See how I'm on the graph? This blue one, if it jumps across, it's here. This green one, it jumps across, it's right there. No matter what point I pick on this V, if I jump it across the y-axis, I'm back on the graph. So this one is even. Okay, here's another picture. I've got this parabola. This red dot, if it jumps across the y-axis, it's here. The blue one, the green one, the orange one. So this one is symmetrical to the y-axis, so it's known as an even function. Okay, then another function here, looking a little bit more interesting, but notice I grab any point on this graph. So this red point, if I jump it across the y-axis, it lands back on the graph. This blue one, I jump across the y-axis and I'm on the graph. The orange one jumps across, notice it's 5 away and it's 5 away. This one here, if it jumps across, it's on the graph. So this is symmetrical to the y-axis, so the function is known as even. Okay, here's one here. This is a parabola over here. And with this parabola, if I grab a point on the parabola and I go across the y-axis, I'm not on the graph. If I take this point that is 3.5-ish away from the y-axis and I jump it across, I should be there and I'm not on the graph. So this one is not even. So if you are symmetrical to the y-axis, again, if you could picture folding this together on the y-axis, everything matches up, then it's also known as even. So silly way to remember it. I mean, this really is kind of stupid, I'm not gonna lie, but you're like, greetings, Mrs. Edwards. Even. Why, yeah, even. So when you see me, you can say, even, Mrs. Edwards. And I'll know that you know that if it's symmetrical to the y-axis, then it is known as even. Okay, now, if a function is odd, it's a double jump. You're gonna jump the points across the x and the y-axis. If I grab this point on the graph and I reflect it across the x-axis, so see how right now it's about 2 away from the x-axis? If I jump across the x-axis, it's 2 away down below. And I put a little x there, like a temporary holding place. Then I jump this one across the y-axis, and right now it's 2.5 away. So I go this way and it's 2.5 this way, and I'm back on the graph. Okay, this red dot right here, if I take this point on the original function and I jump it across the x-axis, I'm down here. Then I jump it across the y-axis and I'm over here and I'm back on the graph. So no matter what point I grab on the original curve, if I jump it across the x-axis and then the y-axis, I'm back on the graph. Okay, so here's another example. I've got this cubic function. If I take a random point on the cubic and I reflect it across the x-axis, I'd be down here. And then take that point and reflect it across the y-axis and I'd be over here. So no matter what point I grab on the original function, jump across the x and the y, I'm going to be back on the graph. So this is symmetrical to the origin. So the name of this so far, if the double jump happens, then your function is symmetrical to the origin and is known to be an odd function. So here's one extra example. If I take this point on the line and I jump across the x-axis, I'd be down here, and then I jump this point across the y-axis, I'm here, but notice I didn't land on the graph. So this point isn't going to get me back on the graph. So this one is not odd. Now if I checked as well, this one would also not be even. If I take this one, jump across, I'm not on the graph. So this graph is not even and it's not odd. I would say it's neither.